Right, because if you look at this ring, it says magnetic. That's the first way. What's the second way we know the inner ring is magnetic? It says right here that the variation of where we are, and again, I'm realizing I shouldn't have put this early to get you guys into a charting exercise until I explain deviation. In 1990, the variation, meaning the difference between the true North Pole and the magnetic North Pole, is 15 degrees west. Okay? And so guess where this magnetic arrow points on this compass rose? 15 degrees west of 0. So that's another way to know that this one is magnetic. There's a third way to know. What's the other way to know that the outer circle is true? Why do we know the outer circle is true? Because 0 and 180 are going to be parallel to lines of longitude that are long that go through the poles. And 270 and 90 are going to be parallel to the latitudes, which are the ladder rungs that we're going to climb up, or the little latitudes that Jimmy Buffett's band is going to take us down to. Right?
To change our attitude.
So let me walk through this one more time. So we're on a boat. We're stopped somewhere in the middle of Long Island Sound. The only thing we have is a chart and our compass. And we say, shit, I want to know where I am. Okay? We look around. We see a bunch of stuff, but we see 3 very visible marks. Those 3 visible marks we see are this red here, which we think is R8A. We can confirm it by getting out our big binoculars and looking at it. And I can see the 8A on it, right? We see something else. We see a lighthouse up here on a breakwater. That one we know what it is, okay? It's a lighthouse. And we can also barely see this one, but this one's a bigger one, and we can see that one. And we get out our binoculars and look at that, and we see it looks like it says 8. Maybe it says B, but it could say 8. I'm not going to make an assumption, right? But let's assume it's 8. Okay? So we see these 3 things from our boat. We take our hand-bearing compass, and we say, I see these 3 things. To orient, there's my clicker. You tell your mom, I told my clicker. I look through my hand-bearing compass at the first one. I say, oh, my compass reads 305. I'm going to write that down. Oh, I see the lighthouse. I'm going to look through my hand-bearing compass. The lighthouse bears 020. Oops, I dropped my compass overboard. So I go to the binnacle on my boat. I go to the compass on my boat, and I move my head around in a strange position so that I can see that other red, the center line that sticks up in the middle of the compass, and it looks like it reads 049. We're going to assume that this compass is hand-bearing compass, and that one reads exactly the same thing. Okay? So the information I've given you is that that mark bears 305, the lighthouse bears 020, and red 8, what we think it is, bears 049, all magnetic. Those are 3 what we call lines of position. So we know, we believe, that since this bears 305, we are somewhere along this line. But we don't know where yet. But guess what? We've got another one here that bears 020. So now we've got 2. And we've got a third one here that bears 049. Now guess what? Those 3, when I did the exercise, and here's how I did this exercise, by the way. I drew these lines, and in PowerPoint, I literally moved them so they were right over. So, I picked that number so the 3 would intersect. But usually all 3 of them don't intersect, right? They're going to be a little bit off because maybe I read the compass number, and maybe I read 047 because the boat's moving around, right? So what you're going to end up with is probably not 3 lines intersecting, but a little triangle. Right? A little triangular area. And you're pretty sure that you're within that triangular area. Again, if you don't have your electronic GPS telling you to 2 centimeters exactly where you are, you're using a visual point. That's what pilotage is, using a visual point on land to be able to determine where you are. Yes?
What if I can't see a visual point on land or anything to mark myself?
Well, then you're screwed. Hopefully, if you can't see anything on land, you've been dead reckoning.
Okay.
And you know your approximate position because you've been dead reckoning. Right?
And if I hadn't because one reason or another, well, what do I do next?
you start trying to figure out where you are, right? So one of the practice examples I give is, and I can pull it up if you want to look at it, but you're out towards the race, and all of a sudden, all of your electronics go, you're in fog, you have no idea where you are. But you remember looking at the depth sounder, 2 minutes ago and seeing 300, and you're like, damn, I didn't know Long Island Sound was 300 feet deep anywhere. Well, guess what? There is an area out by the race where the sound is 300 feet deep. And so if you look around on the chart, you could say, I'm probably in this area that's 300 feet deep, okay? So from that, you could then say, what am I going to do? I want to go towards something that makes a sound, but isn't right on land, So you look around and you say, oh, guess what? There's a whistle at Race Rock. So let me go towards Race Rock, right? As you get closer to it, hopefully at some point the visibility is going to be such that you can actually see Race Rock. Maybe not, right? So then you would have to go from being able to hear Race Rock to being able to hear something else. And if it's so foggy that you can't figure out where, you know what you do? So I teach this in my boating class. If you're in a problem like that, it's hard to do in 300 feet of water. You drop your anchor and you wait.
Till it clears.
Till it clears.
Yeah, but what about avoiding those barges and stuff that can't turn?
They'll see you.
So, yeah.
They'll have you on
They'll
radar.
have their clear.
They'll let you know.
Your level of danger is high.
Yeah.
You're going to say, I know my location and my level of danger is high. Hopefully your handheld VHF is working. Hopefully your handheld VHF is working, right?
Yes.
And you could get on your VHF and you could say something to the effect of pom 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 pom, because this is a mechanical failure that puts you in near dangerous situation. Okay? So it's worthy of doing a pom pom. So you say pom 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 pom. This is a power vessel Serenity, or 56-foot blue motor hull vessel located approximately 2 nautical miles southwest of Race Rock. We've lost all electronics. We are anchored in heavy fog. All captains, please beware.
Is that 9 or 16?
16.
Okay.
That would be, honestly, if you're out in a heavy shipping area
Right.
and you've lost everything, that's worthy of doing a pom-pom. It's absolutely worthy of doing a
So
pom-pom.
there you're just trading off the level of risk of colliding with something or putting down and maybe getting hit or running up on the rocks. You're just weighing those two.
Weighing those two options. And I know which one I'm going to pick every day.
Right.
I'm going to put the hook down because A, they're going to see me on radar, and B, I'm going to make a radio call, right? And C, if you've ever been in that situation in a sailboat race, Joe, you and I have been in this situation together, right? One of the scariest things is when you're doing a sailboat race in eastern Long Island Sound by the gut and by the race in really, really light air conditions, because when it's foggy, it ain't blowing 20, it's blowing 1 or 2, and you hear all around you, every direction, there's a different barge. You know there's a high-speed, ferry that's coming at you. It's scary. But if you're a good navigator, now, most race sailboats don't have radar, unfortunately. But if you have your radar, you got your radar there. And you're looking at the radar and you're being able to tell where these boats are, and you use your radio to communicate with them. And you say, please don't hit me.
If your electronics are down, your radar's up.
Yeah.
Is that the radio?
Handheld VHF. Because why? 2 is 1 and 1 is none. You always have a handheld VHF. Unless you're on a dinghy in Mystic, Connecticut. It's another story.
I have a picture.
So Craig, what are the radio calls? You said that you dropped the hook. What do you say?
Pom pom. So there's 3, and there's a section where we'll go through this, but there's 3 levels of calls that you can make, right? They're distress calls. So the most severe one is Mayday, right? Next one down is pom pom. So Mayday means life and limb is at risk. The boat's at risk of sinking. The boat is sinking. It's serious, right? Pom pom means that you have a situation which could get critical, but you think that you can handle it for now. And so the reason that it's a pom pom call is because you've lost your electronics. So you really don't know where you are, right? You have no way to navigate. You're dropping an anchor in a heavily traveled area, and you want to make other people aware of it. That, to me, is worthy of doing a pom-pom. Because guess what? The Coast Guard might say, we've got a boat 3 miles away. Let's get over there and get this guy a tow, or go 5 feet off his bow or whatever and get him someplace that's safe, right? So Mayday, pom-pom, and the third level is it's pronounced Securite. And so that's a call to inform someone. So the security call that you hear around here all the time is, and they a lot of times say security is, security, security, security. This is the barge, Miss Lady, channel 1613, pushing 2 out of Stanford, southbound for New York City, standing by 1613. Right. So what they told you is, I'm a tugboat, I'm pushing 2 barges, and I'm leaving Stanford. And stay the hell out of my way. Right. Now, look, the guys are great. If there's a situation, anybody at sea is going to help somebody else. They may be pushing 2 barges and have a deadline, but if there's a boat that's in danger, every single captain out there is going to stop and do the right thing, because they want that same thing to happen for them as well. So there's a section, and it will be in the PowerPoint, that goes through those 3, kind of what the protocols are in those 3, and the exact language that you. And at the end of the day, whether you're official or not in a pon-pon or a mayday call, doesn't matter. Mayday, mayday, I'm in trouble. I'm sinking and I'm by race rock. Can somebody help me? If that's all you say, the Coast Guard's going to get it, or somebody's going to relay it to the Coast Guard. They're going to start to ask you the questions that you, in theory, should have put out in a mayday call. Size of your vessel, characteristics of your vessel, color of your vessel, number of passengers on board, type of injuries if there are any. Right? Those are things that you would naturally give in a mayday call. Make sense? Before we go on from this exercise, did everyone get this? Does anyone want to spend any more time on this? Is this helpful?
Yes.
Yeah.
Ready for a harder one? I have a harder one. With this. Anybody have the time? What time is it? 8:30. Okay. So we said we go.
To 17 seconds.
So I had some pictures of some hand-bearing compasses. This, by the way, I couldn't find it. I love this thing. It's called a KVH data scope. It's electronic. Now, the only problem is it's electronic. But the neat thing about it is it has 2 settings. And so if you're on a boat that's rocking, there's an average setting. So you can hold down on the button, and when you say, oh, I think all the back and forth, left and right I've done on average is good now, and you let off the button, it averages all those readings over a period of time. So, and this, in case you didn't figure it out, this is what looking through a hand-bearing compass might look like here or here. By the way, this one is this hand-bearing compass right here. And this is a lot of binoculars. I don't think mine have it, because they're not, I find they're not as accurate, but a lot of binoculars have a compass built into them. I will warn you, binocular compasses aren't nearly as accurate as hand-bearing compasses. Because,
magnetic also, Greg?
say again?
Are they always magnetic also?
Yep.
Okay.
Yep. Okay.
So do you like that yellow one?
I do like this yellow one. It's my second favorite. Where's the gray one? Yeah, the gray one's my favorite. That's what I use when I call tactics. Yeah, that's a very good, they call puck, hockey puck, or hand-bearing compass. Yeah, that one's my favorite. I find this one is generally good, but because it's got some dark in it, in low light conditions, it's hard to get a bearing off this one. That one's pretty good at just about everything. That's why I like that one. We're going to do a more complex one. Okay. So, how do I want to do this one? Maybe make it a little bit easier. That's okay. We'll just do it as a plan. So there is another. So in the last question, we figured out where we were. Okay. There's a technique where you can also figure out how far off you are of something. That's used all the time in pilotage. So it goes something like this. So you're on a boat, and you're going on a course. So notice what this says. C of 080M. By the way, I made a mistake in my previous slides. I should have written 049 and 020. I didn't. I apologize. It should always be to 3 digits. So C080 magnetic at 6 knots. So I'm in a boat and I'm going this way. Okay? And I want to know, let's say that the only thing that I have is my compass on the boat and a clock. And I want to know how far off of Long Sand Shoal I am, because maybe I'm in a boat that's got a lot of draft and I'm worried about making a left-hand turn and how much time I might have before I get over there. So how would I do that? How could I figure out how far off Long Sand Shoal I was?
Local conjure.
Any ideas?
Well, you could do a perpendicular line to that known safe point.
The known safe point. What's the known safe point?
Well, to the east point of Long Sand Shoal.
Okay.
And so you do you carry that perpendicular line to your course,
Okay.
right? So you drop it down to 080,
Uh-huh.
and then you figure out did you do any sightings for any of the other?
I haven't done anything yet.
Oh,
My question is, I want to find out how far away from Long Sand Shoal I am, using only pilotage techniques. I've got no electronics. All I have is the compass on my boat and a watch. How would I figure out how far away from Long Sand Shoal I am?
well, if you could do those sightings from the west and the east of Long Sand Shoal
Yeah, could do that one.
and intersect that.
Let's say the visibility's not that
And then you can get
good.
your dividers and
Let's say the visibility's not that good and the only mark I can see is that one. Let's say visibility's a mile. And I can't see any other mark. The only thing I can see, let's pretend that this mark here, just pretend that's not there. Let's say that is the only mark I can see. If I can only
Where you
see,
are right now?
huh?
Do you know that you're in that triangle?
That's the boat.
Yeah.
All you know is that your boat is somewhere in this general direction, in this general vicinity, and that you're on a course of 080 magnetic, and the only thing you can see outside the boat is that mark. What would you do?
Use the button to get up there to get the angle.
So let's triangulate it. Okay? So I'm going to tell you what we're going to do, and then I want you to graph it. Okay? So here's what you would do. And it doesn't have to be a 45-degree angle, but doing it as a 45-degree angle is really easy if you want to plan ahead a little bit. So what I would do is I would say, okay, what's 45 degrees away from my course? 35. 35 magnetic. So I'm going to record the time that this mark bears 35 magnetic.
Wait, how do you know it's 45 degrees away?
That's a number that I calculated.
35.
I'm saying you could use any number. You could, if you wanted to, you could just read your bearing right there and then wait some period of time and read it again. I'm saying if you have the luxury of waiting, do 45 because it's simple math in the triangle. You'll see in a second, just bear with me, okay? Let's say that it just so happened to be, let's say you were back here a little bit and it read, 040, and you said, wait a minute, that's a 40, if I wait just another 30 seconds, it's going to bear 035, okay? Which is going to make the angle between my course and this mark 45 degrees, okay? So I'll take the time that I do that.
You didn't use the three numbers.
I know.
Just saying.
Was in a hurry, sorry. So, let's say then you're trucking along at 6 knots on your course of 080, and I want to complete the triangle that I'm going to solve for. So I know that I want to make this a 90-degree angle here, right? And so if I'm doing 080, what am I waiting on the hand-bearing compass to read? You're waiting 350, right? So you're sitting here looking through the hand-bearing compass. You're saying, okay, I'm trucking along, I'm trucking along, trucking along. You could say it's 349, whatever. And you could say 350 mark if somebody else is there. Or when you get, okay, it's 350, boom, you look at your clock and you write down the time. So what you've done is you're going 6 knots this way. You have a triangle that has a 45-degree angle here and therefore a 45-degree angle here, because we all know that 3 angles in a triangle adds up to 180 degrees. You didn't know that was going to be math involved. Sorry, it's navigation. 5 minutes later, you get at a bearing 350, which makes this a 90-degree angle. So you know you've got this neat little triangle here, right? And guess what? That's easy math to solve. That's why you make it 45 degrees. You're going 6 knots. You've covered it 5 minutes, right? So it's just the elimination. So 5 minutes is what part of 60.5. So you have traveled 0.5 nautical miles here. It's a 45, 45, 90 triangle. So how far away from this are you? Same, 0.5. Does it make sense?
It does, but Greg, is this a formula that you use or do you get to know these metrics over time?
What metric is that?
So in 6 knots, for example, equals 5 minutes in your boat, is that just?
I just made it. I made it up. Yeah, it's a made up number. You can put any number for 6 knots that you want,
watching it,
right? You could put 20 knots.
of course, and reading it.
218.
But it actually
Right.
says 30
So you just have to change this. So if you're doing 20 knots,
for this.
so at 20 knots, which is 20 nautical miles per hour, and you measure some distance over 5 minutes, right?
So you're just trying to figure out,
You're trying to figure out how long this part of the triangle is. You could also use the old SOHCAHTOA if you wanted to, sine, cosine, tangent, to be able to solve for a triangle. So now back to your question, does it have to be 45? No. You could take a bearing wherever you are. You can wait 5 minutes exactly and take another bearing, and you can end up with a triangle that looks like this, right? You got one mark here, you take a bearing, you know you're going some speed here, you take another bearing there, right? If I know my speed and I know the time that I traveled, I can calculate that there, and I know okay, so you can calculate that, and I know this angle because I know what my speed is, I know what my course is, and I know what the bearing was here. So I can calculate this angle. Look at this. I can then figure out using trigonometry that length. It's a harder equation. And you got to have a calculator to do sine and cosine unless you're really good. Which is why you try and do a 30, 60, 90 or a 45, 45, 90 because those are easy to figure out if you're going to do this. But the point here is that using the basic concepts of trigonometry and plotting where you are based on dead reckoning, based on pilotage, because your pilotage, you know this is a line of position, right? We talked about lines of position earlier. So you could be here, you could be here, you could be here. You know you're someplace along that line, and you know you're doing 0, 8, 0. And that's all you need to do to be able to solve how far away you are. Yes, no, perplexed.
Any other way I can figure this out besides the one we just did? Is there another option?
Turn on your GPS.
Okay, but I can't. I'm just curious if there's another way you might do this. If my trigonometry worked so up to par at that moment.
So that's a good question. So is there another way to find out how far away you are from something if you can't do this? The answer is yes, there is.
Is it going to be more than
And it was in my last RYC sense.
Okay.
All right?
Oh, that one, yeah.
45
So
degrees.
I hope everyone read it, right?
50 degrees says it's west.
So it's harder, it's a little trickier to do than you might think, but if you know what part of something you can see over the horizon. So for example, if you knew that this was a 100-foot lighthouse, and even if you estimated that this top part of it was 10 feet, right? And that's all you could see, so the horizon was basically like right there. It's still a trigonometry problem. I'd like to tell you it's not, but it's still a trigonometry problem, except instead of the angles being this way, the angles are this way. And that's what I put in the RYC sense was about, seeing an object just pop over the horizon, how far away is it? And there's reference tables, by the way. One of the books that if you don't have, everyone should have, is the Eldridge Book Guide. And one of the things that's in here that I won't be able to find is there's actually a reference chart in here that says how far away you can see things of different height. Right? And remember, it's not only the height of this, it's also the height of your eye above the water. Your eye above the water, not your eye above the deck, your eye above the water. So if you're on a boat and the deck of the boat's 3 feet above the water and you assume your eye's 5 feet above the deck, your eye's 8 feet above the water. If you're in a barge with a tower, your eye might be 40 feet above the water. And guess what? That guy's going to be able to see this lighthouse a lot further away than you are. So the trigonometry to solve that one is going to be here. So that is another way to do it. There is also other ways to do it if your GPS isn't working, but your radar is. You can do that as well. If you can find a buoy that has a light and a sound, you can calculate the difference between when you see the light flash and when you hear the sound. it's like thunder and lightning. Thunder and lightning happen at the same time, but you can approximate how many miles away something is by counting the number of seconds between the flash and the boom.
Right.
Same concept works. So if you see a, Morse code flashing and sound gong, and you see the first flash, and it's 5 seconds later when you see, when you hear the sound, you can approximate that that's 5 miles away. Very rough.
So if I take a bearing, I get a bearing of 350 from my position, which is the red mark. And I'm gonna get it, and I just track that, and I'll get another bearing of 350 further down. And when I get,
You're taking the time. So you've taken this first bearing, it's a 45-degree angle. So to keep the math simple, you want to
I'm taking the first bearing is 350.
So your first bearing is 350.
How about my first bearing moving ahead to the left? My boat's the red boat.
35.
That should be 035. 035. Sorry. Yeah.
035.
Yeah.
Okay.
35, not 30.
35. So your first one is 035. So the reason you're waiting to 350 is because you know that's 90. You know your course is 80. So what's 90 degrees off of 80? 350. 0 would be 80, so you have to subtract 10 more and get to 350. So that's why you record the time when you get to 350. It just happened to work out to a very nice, exact 5 minutes. Your eyes look glazed over.
Greg, just run that by me again, please.
Yep. So you're on a boat in Long Island Sound. The only thing that you can see is this red buoy.
Not that piece.
Okay.
That's the last one.
The last piece. So your first bearing is 035, which is a 45-degree angle off of your course.
Cool.
Okay? So you say to complete the triangle, to find a 90-degree, what bearing do I need to record the time at? The bearing needs to be 350. Because if my course is 080, 90 degrees to 080 is a course of 350. So I continually take sight bearings on this as I track along, right? So it's 35, it's it's 25, it's 15, it's 5, it's 0, it's 355, boom, it's 350, take the time. So I knew this time when I took this bearing, I knew the time when I took that bearing, and therefore you can solve the 45, 45, 90 triangle. Because you'll know how far you've traveled in that amount of time because you're doing 6 knots. Which, because it's a 45, 45, 90 triangle, means that this distance here will be the same distance away as the distance you traveled in those 5 minutes.
And this is probably obvious if you're off the water, that it's not 170. You're not adding 90.
You just take the reading off the compass. I mean, if this is the only thing that you can see, Paul, if this is the only thing you can see, if you turn your hand-bearing compass to 170, what are you going to see over there? You're not going to see anything. You're going to see fog, right? And so the only thing you can see is that red buoy, and so you're going to keep the compass on the red buoy that you can see. Make sense?
Right. Got it.
Yes?
You walk us through the formula one more time? The formula, 6 knots, got the 6, I got that.
Yeah. So it's simple. So I'll write it up here on the digital very well. So what is 6 knots? 6 knots is 6 nautical miles in 1 hour. Okay? Right? And so math is, you're trying to solve for minutes, right? So 1 hour is how many minutes? 60 minutes. We're going to continue it down here. How many minutes did we travel? So we traveled 5 minutes. So this is going to give us, when we solve it, 6 nautical miles per minute. So it's 6 divided by 60 times 5, or 6 times 5 divided by 60, 30 over 60, 0.5. It's the old, you got to cross that, 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 and you're left with, right? You guys remember that from?
Yeah.
I should have put a prerequisite for the course, maybe. 4th grade math. Yes? Are we?
We're with you.
Proceed?